Okay, let's look at part 2 of kinematics. Constant motion. No vectors here really, just straight up common sense motion. Now you might go, what's this picture about? You can look it up. These are the sailing rocks of the desert. These rocks move by themselves. That's all I'm going to say. If you're curious, look up sailing rocks. We want to be able to compute average speed, distance, and elapsed time. The delta notation, the little triangle, hopefully you've learned. Delta y over delta x for slope. Delta means difference. We're going to use a basic equation. V bar, which is V average, is d over t. V bar is not the same as V arrow. This means you must report a direction. This means you have averaged it. If you have a scientific calculator, you may actually see a bar over one of the letters, and it would give you an average of a set of numbers. Delta means a change. I put it in a different color. When we write V equals d over t, it is implied that it is delta d over delta t. What do I mean by implied? If you said, how long have we been driving today? And a person says, 12:15. I didn't ask for the time, you idiot. I asked for how long we've been driving. Oh, well, you started at 10:15. Now it's 12:15. In order to get a time interval, you need to subtract the two times, unless you have a stopwatch. Delta D, if you're using a tape measure, you just assume that the beginning of the tape measure says 0. But if you ever used a school ruler, some of those rulers are a century old. And boys sword fighting with the rulers for the past 50 years, usually they're missing the first centimeter. So what have you done to measure something when you can't read the first little bit of the ruler? You go, oh, I measured 30 centimeters on one end and it ended at 2 centimeters. Okay, so 28 centimeters. So this is what I mean. There's an implied delta and a delta here because you need a starting and an ending point. Just with stopwatches and rulers, you can force both to be 0. Even your car has a trip odometer where you can hit a button and reset it all to 0. Prior to those things being invented, people used to have to read the odometer at the start of their journey, read it at the end, and do a thing called subtraction. We're going to look at constant speed only. And there are 3 variables we can take into consideration. Elapsed time, t or delta t. And if the initial time is not 0, we can use tf and ti for final and initial. In math class, you use y2, y1, x2, x1. I hate interruptions. Distance is d or delta d. And again, we'll have final distance and initial distance, but in many cases, initial distance and time will be 0. And since speed is a constant, we don't write delta v. That comes later. Your best practice is to set up a list of the possible variables you will need and fill them in from the problem given. Typically, you would write d, t, and v and write in the values. But if I'm being particularly mean that day, you might have to fill in more than that if the initial values are not 0. So if you get a problem that involves this, I like you. If your problem involves this, I'm just being mean. Let's try a simple example, numerically solving for V. A transport truck drives 75 kilometers in half an hour. How fast is it traveling? You can locate your variables in the problem. If you struggle at all with reading or struggle at all with identifying things, get a highlighter. It'll make a huge difference. You may have noticed in most of my problems, I have put in bold the key terms. I sort of predict that there will be students with an IEP or eyesight difficulty, and I try to draw it to your attention. But if it hasn't been, isolate them yourself. Then we list the knowns and unknowns. We found in the word problem 2 variables, and we were asked to solve the third. Doing this would convince the teacher you were aware of the setup. How much longer would it take you to do this and that as a preamble to your problem? Then we want you to write out the formula and finally put in the values for the formula. Now, I didn't do that methodically because I'm on screen and I have limited real estate. So you would write out the formula like this, and then right afterwards you could just put equals and this part, and then to here. I faded it out so this part here would just be to the left of this. I just wanted it to stay big on the screen. Notice I've put my units in a different color. If, again, you get confused by adding units, get a second color of pen. And then you get your answer. I like the answers to be boxed or underlined. I do not need you to write out a sentence answer at the end. If you gave me a problem set up like this, you'd get full marks. Now the question is, how much extra time would it take you to do this and this? And that way, if you flubbed this part mathematically, right, I could say, boy, the kid knew what they were doing. They were setting up everything perfectly. Because a lot of people will decide 75 divided by 0.5 is 37.5. And you'd lose all your marks if you just wrote me an answer. Now, if you feel like skipping these units, you've done arithmetic, not physics. In physics, these numbers must go out fully dressed in units. I don't want any buck-naked numbers! Keep the units. Now, what about the other two? What if we wanted to solve for distance or time? Only one of these can be unknown. So we need to rearrange the equation to solve for d and t. You may have done equation rearrangement in math class, and I used to teach it as well. It either sinks in with students or it defies their brain all through high school. So years ago, I decided to take a different approach. Physics has meaning. In math class, they're just numbers. Here they have meaning. So what I want to do is take you from a general example that you can figure out in your head to creating the formula that goes with it. I'll show you what I mean. You drive at a speed of 100 kilometers an hour for 2 hours. How far have you driven? "100 kilometers an hour for 2 hours. Everybody can instantly tell me that answer. Now, how to make a formula out of it. What did you just do with the idea of V and T? What did you carry out in your head? That's your formula. Write it down. Distance equals what you just did in your head. You've got the formula. Let's try the next one. You are planning to drive to Owen Sound, which is 131 kilometers away from my house. You are driving at 85 kilometers an hour. How long would the drive take? What makes sense mathematically here? You have a 131 kilometer journey. You are driving at 85 kilometers an hour. You'll probably need a calculator for this one, but you could ballpark in your head roughly the time. What are you going to do with those two numbers on your calculator? How are you going to calculate the time? You're going to multiply them, add them, divide them? Which way are you going to divide them? 85 over 131, 135, 1 over 85. What makes sense? And the minute you do that, you've just created your formula. Now all you have to do is take this and change it to its letter. Take this and change it to its letter, and you've rearranged and created a formula based on your understanding of the world. And that's something you cannot do in mathematics. And this is one of the powers of physics. A lot of these equations, you can think your way to the answer because they are dealing with things you have perceived in your life. It ain't going to work for Einstein's equation. It's not going to work for orbits of electrons. Those are beyond our perception. But you've seen things move. And so you should be able to do these in your head. And that gives you a strength in physics that you can't have in math. This is the way a math teacher would do it. He would say V equals d over t. And rearranging formulas mathematically is a very important skill. But it's up to the math teachers to teach that. I find repeating it hasn't improved student results. I want to show you a different way. But this is how you do it properly in math class. And this is how physicists come up with new formulas. We want to get rid of something. So if I want to solve for distance, I need this time out of there. Since it's divided by time, if I want to move it to the other side of the equation, it inverts itself. We multiply both sides by time. We cancel. And we get the formula that you used common sense to generate on the last slide. There's your answer. That's the formal rearranging approach. But I want you to be convinced in your head that you can think your way to these answers in many cases. Now, why did I write d equals vt and not d equals tv? Because it looks stupid, that's why. In science and in math, we always put time at the end. You could put time in front of the v, but you look as idiotic as a person eating a corn cob from the end. It's just accepted that we put time at the end. In math class, again, you are only handling numbers. But in physics, we've got units. Let's look at a classic problem, solving for x. So you got the pirate there, ship, and there's an x. 7 equals 14 over x. My goodness, what could x be? What could I divide 14 by to get 7? 2. And that would be your sort of math solution. So here's what your friends come up with. Your friends just randomly go at this. They just like start slamming away. Oh, I'll just try. One friend says, it's 7 over 14. The other one says, no, it's 14 times 7. And the other one says, it's 14 over 7. And then finally someone says, why don't we like do something collegial and like communal, all like liberal snowflakey? And average our numbers. So we come up with 33.5. And if you think I'm making that up, you wouldn't believe the random guesses I've seen over the years. You either know how to rearrange this mathematically or you don't. So I will see students just stabbing away at all possible variations. But let's take the example and turn it into physics. Right? In math, you can't possibly verify your answer. But physics, something happens. If v equals d over t, does your arrangement lead you to which formula? Again, I hope you saw by common sense and by using rearrangement that this is the correct answer. But let's suppose you're on a test where you were told to memorize the formulas, or you're just getting confused and you're going, which one of these could be true? It turns out that the units will tell you how stupid the wrong formula is, something math cannot do. Here's a simple example. You know, in classroom questions, they always have like, your friend says, no, this person is your arch enemy. Someone you just want to die. They suck. And they say to you, area is 2 pi r. And you're like, no, you bromo, it's pi r squared. What are you, from Marsville? And they're like, no, area is 2 pi r. And you're saying, it's pi r squared. And your best friend is like, well, you know, we should come to a mutual agreement. And you're like, look, doofus, if I take 2 pi r and I ignore the numbers, I just pay attention to this R. R has units of meters. And meters is not area. It's meters squared. You're freaking wrong. You've given me the formula for a circumference. It's just a straight linear measure. The concepts we are measuring of distance are not what area is measured in. That'd be like saying Toronto's 80 cubic centimeters away. How heavy is that? Oh, I know, like 37 degrees. Wow. No. The formula's wrong. Doesn't matter the numbers. The units are wrong. And then you sit there and stick the dagger in. You go, you know why I know I'm right? Take away the 2 pi. My formula has meters squared in it. So my formula is the correct one. Now, you could be an idiot too and you wrote 4 pi r squared. But the fact is, the units are telling you you've made a mistake. You've not done the formula correct or you're in better shape. And this saved my bacon in university. I was the rare person that had higher physics marks than math marks. Usually it's reverse. The reason being is when I made careless errors throughout the problem, at the end, by tracking the units, I'd suddenly get the distance to Toronto is 4 square feet per degree. I screwed up somewhere, and I could find my error. So dimensional analysis becomes so important. So let's look at the 3 possible equations for distance, and you'll see what I mean now. Speed over time is meters per second per second. That's not distance. What? Distance is time over speed. That's seconds per meters per second, which is seconds squared per... That's not distance! That's distance! Ow, it's this formula! You see what I mean? Now, I've had more than 30 years extra practice than you guys. It's going on half a century. Obviously, I'm quick at this. But I want you to start really paying attention to this because it will make so much difference in terms of the ease with which you can do physics. Now, common sense along with the formula. A car drives for 2 hours at 100 kilometers an hour. What is the total distance it drives? 2 hours, 100 kilometers an hour. Total distance. There's our setup. Formula. Values. Answer. What's the difference? Prefer you draw it this way. Why? Because here it's messier looking. When you look at it this way, you can see the H and the H are going to cancel. It makes it much easier to convince yourself that the units are correct. Now think about your answer. You drove for 2 hours traveling 100 kilometers every hour you traveled. Does it not make sense to multiply these values? There is meaning here. Again, this is what makes physics not mathematics. Keep those units. Don't believe me? Try this example. Boss, how much are you paying me today? 4. Huh? 4 what? Golf? Forever? Gotta have units.